Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapiens Education. So today I am going to discuss about the refraction phenomena of the light chapter. So here we will discuss about the real depth and apparent depth relation. Okay. This is the relation between real depth and apparent depth. Right. Now let us observe here. This is what this is the any liquid where it is having a refractive index of mu2 and above is your air, so it has a refractive index of mu1, right? Okay, now let us consider there's an object and it has in this object what happens, light will starts from this object, so it will go thoroughly in a straight line, and there is another light which will go in this direction. Okay, so what happen when it will see what will happen when a light will go from a denser medium to rarer medium, so it will bend away from the normal. It will bend away from the normal. So this is the light. Okay, so it will bend away from the normal. So this is angle of refraction. So let us consider this is an angle of incidence and this is your angle of reflection, right? So this is the phenomena, right? So when it will bend, so what will happen, this I will try to observe that the object will appear to be this point. So actually the object is here, so it will appear to be this point. It means that the real depth was this, but the apparent depth is this, means it will appear to be here only. So we need to find a relation between real depth and the apparent depth. So first of all, we know that as per the Snell's law, what we can say, mu1 sine I1, sorry, it will be mu2, because this is we are have considered as a mu2, sine I is equal to mu1 sine r, right? Now from here we can write here mu2 by mu1 is equal to sine r by sine I. So I hope you have understood this, right? Now we know that if you observe the and observe some of the triangles, so let us consider triangle ABC. So if you consider in triangle AOB, AOB and AIB, so what you will observe here, sine I is equal to perpendicular by hypotenuse, that is equal to AB divided by OB, and sine R is equal to perpendicular by hypotenuse. When you observe this triangle, so what will happen, what you will observe is that it is your perpendicular by hypotenuse, that is BI or IB. So when we put the values, so mu2 by mu1, so this will be equal to sine r, that is equal to AB divided by IB divided by AB divided by OB. So AB got cancelled out, so this will be OB divided by IB. Now you know that if this will be this both light, if the angle is very much, so this won't catch, I won't able to see this, so its angle should be less, then only this I will able to see the object. It means that if angle is very small, angle is very small, so what happened, this both line OA as well as OB both will be equal. So in place of OB we can write here, in place of OB we can write here OA. So in place of OB we can write here OA. So finally we can write here mu2 divided by mu1 is equal to OA. And in place of IB we can write AB because the angle is very small. So here we can write as AI, right? So from this we can say that from this we can say that the OA is our real depth, and AI is apparent depth. Okay, and mu2 by mu1 can be written as mu2 with respect to 1. So from here what we can conclude is real depth real depth divided by apparent depth is equal to mu mu 2 with respect to 1. Okay, or we can say that apparent depth is equal to real depth divided by mu. So mu is always greater than 1, so that's why apparent depth will be always less than the real depth. I hope you have understood this. Thank you for watching this video. So I will again come up with the next topic with the next video. Thank you.